Hi, I'm Karyn creator of John with Geometry Family Math Night. And in this video, I'm going to share with you a super fun activity that we did at a recent Family Math Night event. But you can also do it with your class, and it's also a great project to do with the buddy class as well. So the idea was to have participants create a project that everybody contributed to, and since we had a theme of geometry going on, it made sense that the project had something to do with geometry. So what I came up with was to have participants create individual cells like this, okay, that would be put together to create a huge honeycomb. And to make it fun, participants got to decorate their cells. So I'm going to share with you what the final product looked like, and then I'm going to walk you through the steps of what I did, and then we're going to tie the math in and tie math in to nature. So here is the final product. Super cool. I'm going to hold it at a couple of different angles here so that you can see all those beautiful colors and illustrations inside there like that. Okay. Next time, I'm actually going to see if the parents want to contribute to the honeycomb as well. Okay, so there's the honeycomb. Now, this is how we did it. I cut a whole bunch of tag board or cardstock strips, 3 inches by 12 inches, a whole bunch of these, okay, because the cardstock is easier to work with and fold. Okay. And when the participants came to the station and they were drawn by the totally colorful Sharpies that I had, there's a ton of Sharpies spread out on the table. But you can also use crayons, you can use colored pencils, you can use other kinds of markers as well. And so what the participants did is they created a design on one side of the tag board. So the next step was to turn this into that hexagonal cell like that. Now you can have the older students actually figure this out on their own. I had a whole bunch of rulers at the station, and they can measure that this is 12 inches here, and if a hexagon has 6 sides, then how many inches does each side need to be, and then they would do that little division problem there. There's a lot of fractions involved in this as well, as you'll see. Okay, but you can let the older kids solve that problem, and they're actually quite capable of doing that. Okay, so with the little guys though, is the first thing that I had them do after they created their design was to fold it in half, and there's some more fractions right there. Okay, folding it in half, just like that. Now what I discovered that this is the best time to have them tape their ends together. Because if they don't tape their ends together now, then after it's all folded, okay, because we're going to be folding it like that, after it's all folded and they want to turn it into the hexagon, they end up overlapping it like this. And then of course that changes the whole thing. This is no longer a hexagon, it's a pentagon, and the sides of the lengths are all wrong and it won't fit into our honeycomb. So, okay, so now is the best time to tape that. So it's going to be like that. All right, now with these little guys, I learned that even though I had a whole bunch of rulers there, I learned that the best way for them to do this, and their parents are there working with them as well, okay, but I created a whole bunch of strips, and I did it this way. This is 6 inches long, this piece of tag board here. You can see it's the same length as that strip. And then every 2 inches, so 2 inches and 4 inches, I created those lines down there, and then I cut these into 1.5 inch strips that look like that. Now that's what the little guys are going to use to mark on their tag board. They're going to make little lines, and that's going to show them where they're going to fold. Can you see those lines that I just made there? Okay, so they're going to fold, and the folding is not that easy to do. So again, their parents are there helping them fold. And once they have it folded in 2/3, and this also illustrates thirds nicely, doesn't it? Okay, once they have that folded into thirds like that, okay, you can ask them. So we're going to open this up. You know, how many sides do you think we're going to have? They like to make that prediction. It's going to look like something like this, a little diagonal lines. And so that actually is still a hexagon. Let's talk about geometry vocabulary for a second here. A hexagon is a polygon, and a polygon is a geometric shape with 3 or more sides. So a hexagon is a polygon that has exactly 6 sides. And so we know that this is a hexagon. We normally don't see it like this, but it has 6 sides to it. And what the students need to do is punch out these 2 sides here, okay? And then, of course, there we've got our beautiful hexagon. Now this is called a regular hexagon because all sides are the same length, okay? This is still a hexagon, right? Okay, because all sides happen to be the same length. A hexagon does not have to have all sides the same length, but this one happens to have that. That is still a hexagon. But this is a regular hexagon because the interior angles each measure 120 degrees. Okay, so this is a regular hexagon that we just made. Okay, so now they get to attach this to that ever-growing honeycomb. And they love to come and look and see where their piece ends up in the whole thing. So that is super fun. So now, oh, by the way, a heads up, some of the real little guys get super attached to their little hexagons after they've drawn them and put them together. So a lot of the little guys didn't want to attach their hexagons to the big one. They wanted to take them home with them, and that's okay to do. They can take those home. Okay, so I'm going to talk about some of the math that's going on here. Notice how nicely all of these hexagons fit together. That's because they do something that we call tessellate. A shape that tessellates fits together nicely without any spaces in between. And let me show you some examples here. So here I have my squares. And my squares tessellate because you see how nicely they fit together without any extra space in there. Okay, so now I'm going to take my circles and put those together. And notice how these circles do not tessellate because they have all of that space right there in the center that's left over. So circles do not tessellate. And then we've got our hexagon. So let's see here. Our hexagons. Do our hexagons tessellate? And we know that they do because we just created them. But our hexagon does a really nice job of tessellating as well. And I'm going to tie in a little bit more math and some more angles here. Where these angles meet, okay, need to add up to, in order to tessellate, need to add up to 360 degrees. So you can see here that these angles are 120 degrees. So 120 times 3 is 360. 90 times 4 is 360. And it doesn't have to be the same shape either. You could have, I could put this parallelogram in there, okay, and those still tessellates. Or I could actually still, I could put 2 parallelograms in there. And this is a good activity for your older kids to do. They can figure out, well, if this angle measurement here is 120 degrees, what's the angle measurement of this, okay, parallelogram, okay, that vertex and that parallelogram right there. It's good for them to do problems like that. So, so there you go. Those angles add up to 360 degrees. Okay, so so that's what makes this so beautiful with the honeycomb because it tessellates, it all fits together nicely. Now I want to talk about, I'm going to tie in the nature part of this. I always grew up believing that honeybees created the hexagons when they were creating each one of those cells. And it turns out that research has discovered that they don't. They actually create circles, which is still pretty amazing. But they create circles. And what happens is that the tension being pulled on this circle from the other cells and the heat generated by the bee morph this circle into the hexagon. So that's how those hexagons are actually created. Now, I want to get back to talking a little bit about the tessellation here. The circle happens to be the shape that if you keep the perimeter the same, and the perimeter on this and the circle and the perimeter on this hexagon are 12 inches, and we know that because they came out of the same strip, right? So if you keep the perimeters the same, the shape that's going to have the greatest area, and the area is the space inside there, is going to be the circle. And I don't know how well you can see this, but if I put this circle over this hexagon like that, can you see how there's a little bit of, the circle is a little bit larger there, meaning that the circle has the greater area. Okay, so, and actually we do a really nice, we do an activity in our with geometry kit that illustrates this beautifully to kids. Okay, so we know that the circle has the greatest area given the same perimeter. But nature doesn't like the fact that there's all this extra space in there, and nature is super, super efficient. So what does nature do? It morphs that into the hexagon, because it turns out that the hexagon is the shape that holds the greatest area that tessellates. Okay, and that's a very good thing for the honeybees, because that means that they're going to get the most honey out of that shape, and it's going to be very efficient because you're not going to have any wasted space in there. So nature is amazing, and mathematics is what we use to explain it. And doing fun projects like this is what we get to do to create it. So have fun.